All right, guys, today we're starting 17.5. Should be a little bit easier than it was yesterday, but we do have several theorems that we have to talk about. They need to be memorized. They're not on any sort of a formula sheet, and they're the only way to solve some of these problems. So theorem number one we're going to talk about today. If you've got two chords and they intersect in a circle, then the products of the measures of the segments of the chords are equal. What that means is if they're crossing, each segment's broken up into two pieces, like this segment or this chord right here. Let me change colors. This chord right here is being intersected by this chord. It tells us the two sides of each. So I know this is 12 and this is 3. And then the vertical line, this part is 3 and this part is x. So I can take the pieces of the line and multiply them together. So this line has a 12 and a 12. So 12 times 12 equals, and look up here, piece times piece. Well, 3 is one piece, x is the other. Now I can just solve for x. 12 times 12 is 144. That's going to equal 3x. If I divide both sides by 3, I get that x is equal to 48. So it's just what it says up here. The one piece of the line times the other piece of the line equals the other line, its pieces multiplied together. Let's look at another one. So same sort of thing. I've got this CA segment and this DB segment. If I look at the CA, one part is x plus 3 times, oops, I don't know why I put 4 there, times, well, here's the x plus 3, the other part of the line is 4, so times 4, equals, same thing with the other side, x minus 1 times the 6. Now, I put the x minus 1, x plus 3 in parentheses because you need to remember you have to distribute. So 4x plus 12 equals 6x minus 6. I'm going to go ahead and subtract the 4x and add the 6 at the same time. That gives me 18 equals 2x. And when you divide by 2, you should get x equals 9. All right, so they're really not that bad. These can be a little trickier, and so I want to make sure you understand what each of these are. We're talking about these lines right here, and you have a secant part of it right here, the part that's inside the circle, and then you have like the external secant segment, which comes outside the circle, so it's kind of in pieces. What's really important in a second is going to be this part, okay? So let's look at the next one. This theorem is horrible to say, but it's easy in practice. If two secant segments are drawn to a circle from an exterior point, so look what we have in our picture in example 3, an exterior point and two secants, okay? Then the product of the measures of one secant segment and its external segment is equal to the product of the measures of the other secant segment and its external secant segment. What it means is this. You're going to take the whole thing and multiply it by its outside piece. So the whole thing times the outside piece. If you do that for both sides, they should be equal. Now, if I look first, I'm going to do the whole thing. Okay, so I want the length of the whole line. They told me part of it's x, part of it is 6. So I can add those together and say x plus 6 is the length of the whole thing. Now we go back and just multiply it by the outside, just like that. Now we do the same thing to the other side. This one's a little bit easier because they gave us measures. 18 plus 8 is 26. And the outside part is 8. So 26 times 8. So the whole thing times the outside piece equals the whole thing times the outside piece. Put parentheses on here again so I don't forget to distribute. 6x plus 36 equals 208. And from there it should be pretty easy. So 6x equals 172. I divide both sides by 6. It's a decimal. I got 28.67. So this is going to look a little different in a second. I mean, if you look at the next example, they're not the same. So be careful when you see this connecting outside. The whole thing times the outside piece equals the whole thing times the outside piece. And the last theorem. If a tangent segment, which I have here in TR, and a secant segment, which I have here in SR, are drawn to from a, let me start over. If a tangent segment and a secant segment are drawn to a circle from an exterior point, which is R, then the square of the tangent segment is equal to the product of the measures of the secant segment and its external secant segment. It's a mouthful. what it's basically saying is, guys, if we want to do this first, this is the tangent line, okay? It's not ever going inside the circle. The tangent, we're going to take it and we're going to square it. And that should equal basically the same thing we were doing on the last one. We're going to take the whole thing, which I think it told us this time is 16, times the outside piece, which is x. So I have 144 equals 16x. I divide by 16, and I get that x is equal to 9. So guys, we're going to work on this a little bit more tomorrow, but if you have any questions, just let me know. Good luck.